Hi class, it's Bill back with a continuing video on the observer design pattern. In the first video, we talked about the need for this and what the general ideas were behind the design pattern. And then we looked at some specifics of how this could be implemented with interfaces and why interfaces are so important here. So we are now going to look at a little bit of code so that we can get some ideas of specifically how this might look, and then we'll wrap up with some ideas about how Java supports this. So let's look at some sample code. I have a little simple observer demo, and this was adapted from various sources that I found. So the first thing that we want to notice here is that we have exactly the subject and the observer interfaces. Now, note that these words aren't magic, right? None of the names here are magical. The names don't make something happen. It's just that typically you'll use these names because they're very clear. When you say observer design pattern to somebody, things come to mind, and when you implement them with these names, they're very easy to locate and find what you're talking about. But you don't have to use these words. So let's look first at what's in the subject interface. Remember, the subject is the thing that's the main thing being watched. It's the place where the action is happening that the other observers are interested in paying attention to. So we've created the interface, and it's pretty simple. We have to have a way to attach and detach. Again, the words may be slightly different, but you have to have a way. Hey, give me an observer and I will attach. I will set up the subscription. Give me an observer and I will remove that subscription. Notify all the observers because something has to happen. Then, because in this case we're using what I'll call a pull model, that means when I notify the observers, I am not pushing data out to them at that moment. Instead, I'm letting them ask me when they're ready, because maybe they're not ready for the data. Maybe they have some sort of loop in which they're running and they don't really need the data right now. Maybe they'd like fresher data when they're ready for it. So in this case, that's a pull model where we say, hey guys, there's something interesting in the world, just let me know if you want it. And that way, sometimes observers may want to wait, or you may have various kinds of information available and observers may want to call various get methods to retrieve that. In our case, we're working with time and we're working with a particular instant in time, which is where this Java time instant comes from. So we're saying, hey, you need to have a way to get the state from the subject. We're making it very simple with just this one piece of data. Could be much more complex, as it will be in our project. So you need to have these things to make a subject. What do you need to have to make an observer? Easier yet. You need to have a way to tell that an update occurred. We don't need a subject passed as a parameter because we only have one subject where a simple system doesn't matter. And notice no data is going to come with that either. We don't see that here, but since this is a pull model, the update is not going to take with it data. It's going to simply let them know something happened. So that's the basics, right? That's the basic stuff. Now, we eventually want to actually have a subject, so we have this Greenwich Mean Time subject, and it has stuff that should make sense to you. We have an array list, right, that will hold observers. Again, the data type here is observer. Observer is the interface. So we're using interfaces as a way to sort of serve as a parent, serve as a polymorphic collector, which is super cool here, right? Super cool. And we have our state information for our object. Then when we create this thing, when we construct it, we just make a new array list and we start with an empty list of observers. If somebody asks us for the state, we just return our state data. That's the instant, right? One should probably set that to null somewhere because if they call get state before we're ready, well, we don't know. Something we could probably fix. Now, in this case, I'm also allowing a set state, and that's just because since this is a simple illustration, I have to have some way to actually say, hey, something's going on here. I don't have any kind of other interesting data that's being generated, so I have to have a way kind of to poke it and say, hey, something, pretend something interesting happened. The way that I'm doing that is I'm actually just grabbing the current date, time. It is a great bit of information altogether. I'm grabbing an instant and saying, hey, give me the now, give me this instant in time, store it in the state variable, and then tell all the observers that something interesting has happened. So this is just a way for me to kind of poke it. All right. Now, notice I have to implement notify all observers as well, which is going to be down here. And this just says, look, go through the list of observers and for each one call update. Now this is interesting. We're looking, in my analogy, through observer goggles, right? We're using this as a static type. But that's perfectly fine because the only method we need access to is update, and we know that all observers have that. They could have a whole bunch of other methods that we would have no visibility into as an observer, right, using an observer data type, but we don't care. The rest of it is up to them. Then we have the attaching and detaching of an observer, but that's just really manipulating the array list. So add to the array list or remove the item from the array list. So that's our whole subject. Right? So hopefully all of that code kind of makes sense. In the observer itself, well, we already looked at that interface. Now let's look at one particular observer, like let's say a Paris observer. So we have all these different observers. None of these require, if I want to add another one of these, it doesn't require me to recompile my subject. Right? It doesn't change the interface. It doesn't change any of my existing subjects, concrete subjects. So this is the no compile solution that we're talking about. So to add another one of these, I just add it, right? I just implement the observer interface. So any one of these, like this case, this is Paris. Paris, the first thing that it has to do is it's going to remember what subject it needs to talk to. Right? What is the subject that it's going to attach to? It needs to have a way to remember that. And actually, yeah, it's an interesting question whether it needs to do this at all. Some of these you'll see that they don't even retain a reference, right? They don't necessarily need to. But in this case, yeah, we're gonna make an introduction here. If you think of it, in main or whatever, wherever we're establishing this, we need to establish the relationship between the observer and the subject has to register itself. So if nothing else, for this one moment, we have to be past the subject so that we can register ourselves with them. Whether you retain it here or not is another matter. And then here's the code of interest. When I get an update, right, when I get this notification that things have updated, I'm going to call the subject, right, in this case I do need to retain this, I'm going to call the subject.getState. For a pull model I got to know who to talk to. So I'm grabbing that instant out, I'm setting the zone ID. This is a special string that it knows that Europe Paris is one of the zones that it knows about. I'm creating a thing called a zoned date time based on that zone ID and the instant that I grabbed from the state, and then I'm printing out the time in that particular location, like time in Paris. All of these observers do the same thing. Right? They all do the very same thing, just for different time zones. These could have, again, very different purposes. Why does a particular observer want to have the exact time from the particular server on which the subject is running? Now we're running local, but you get the idea. I don't know. Whatever reason they want the time for, they can do it. They don't even all have to be related as closely as these happen to. The strange thing about it is that that is the code, that all this stuff is going to work with just a little setup from main. In fact, in the project that we're going to do, the main code is going to be almost as simple as that because we're going to have a GUI. But for us, what we need to do in main is we need to start the subject, and notice that needs to be done first because you've got to have the subject to pass to the observers. Now, in this particular one, I created a reference variable, but in these other ones I didn't, which is really interesting. I create a new Tokyo observer and pass it to the subject. Well, wait a minute, doesn't that just get garbage collected immediately after this because I'm not storing it? No, because the subject has a reference to this object in memory. So it doesn't go out of memory, it doesn't get garbage collected because the subject still knows and retains a reference to it in its array list. So that's kind of bizarre that you just have these lines with new on them, right? And in this case I did, but there's a specific reason you're going to see in a moment. Now all I do here is just set up a little menu to kind of, pretend that interesting things are going on. So I have a loop that says just press Y to update, and I've registered all these observers, so I should have Paris, Tokyo, Sydney, and Seattle all registered. And then I have a little thing that lets us remove Paris just to show you that it will detach properly. So the interesting thing is really that is all the code of interest is you're doing the handshakes, right? You're creating the subject, you're creating the observers, and you're passing along the subject so that they can get acquainted. And remember, the first thing that each of these is going to do with each other, right, when they get that information, the first thing these guys are going to do is register themselves with the observer. Yes, with the subject. Keep saying the wrong word. Sorry about that. Okay, so let's look at see how this works. It's kind of amazing code to see working. Okay, so I'm going to press a Y, and there is the time. Now notice, again, this is all very event driven. I didn't call each one of those to do their thing. In fact, a really good thing that you can do in your head is figure out how all of this code got run, right? How did all of this stuff come to run and yeah, how did it all work? What is the sequence in which all of this happened? How did the messages get transferred back and forth and all of that, right? Because that is the interesting part of this observer. Now let me show you, I'll simulate what happens if Paris says, I am not interested anymore. I want to get out. So Paris says, I want to go, so I'm going to simulate that with a P. And then au revoir, Paris. And therefore now Tokyo and Sydney and Seattle all get updated, but Paris isn't called because it's unregistered itself. And I can keep getting these updates as long as I want, and then of course I'm going to press N to say, hey, I'm done with all that, so goodbye. So the interesting thing is that all of this does its work with very little uh, orchestration, I'll say, without very much direction from us. All of the things interact with each other with these wonderful little messages going back and forth, but it feels very hands-off. And when you have a graphical user interface, which we're going to have, it feels even more odd because you kind of just start these things up and your main is not going to have very many lines in it because you're just sort of spinning all these things into existence, and then you're sitting back and everything that the GUI does fires off all the interesting stuff here. So figuring out, again, I highly recommend you download this code if you're in the class and you walk through this and actually line by line. Debugger is great here, right? Set debugging breakpoints at various points and step into and watch everything that's happening to make this code do what it does. It's cool, right? It's very cool. Okay. So again, this is a pull model. There is another one on Tutorials Point. If you look up the observer design pattern on Tutorials Point, you'll find some code there. Some of what I did is sort of, vaguely like what they have. They're doing number-based conversions, but very similar thing. Another place to go is the Headfirst book, which I talked about when we first talked about design patterns. And they have, of course, a chapter on observer. And since it's their stuff, I don't want to bring up their code and show you. I figure that's sort of their business. So there is a link. You can go to the Headfirst Design Pattern book. Their website will have the sample code if you want to grab it. It's again pretty fun, and you'll find that it works well. This one uses a push model, and it is a little more complicated, right? So a push model. So the data goes out with the notification. All right, so one other thing to talk about then is, oh great, I want to build one of these. Can I use Java? And the answer is, if you're doing our project, the answer is no. We want to build one of these things from scratch. But the answer might be in some cases, yeah, you could use it, but let's look at what Java offers and then we'll look at the resources. First, there is an observer interface that Java offers, and it offers an observable class. Now, if you want to make an observer using Java, you must inherit from observable. Note that, inherit from observable, not just implement this interface. So that's a little bit of a problem for us because as much as we thought inheritance was great when we learned about it, it really isn't so great in this world. Why? Because you might have your own inheritance model going, and then how are you going to inherit from this if you already have an inheritance model? You're not. So that is kind of a stopper for a lot of folks. It's a source of complaints on the internet that people say, why did they do that? Why could they not have done it better with interfaces alone, etc.? So there's more details here about if you really want to implement it. It's going to have an update method that tells the subject, which we talked about, and the data. Great. This is fine for a push model, or you can make it null, of course. And then there's some other information here about how you can use those things. There's a set changed method, etc. So you can certainly use this thing, but again, what's the downside? Well, it's a class. So if you have your own inheritance model, not so good. And it's not very easy to create your own that works really well with the observer, the interface stuff that's built in. So it's, again, not really ideal. We don't know why they quite decided those things. We like the idea of favoring composition over inheritance. We like the world being based on interfaces, as you've seen. So it's really not that complicated, as you've seen, to create your own interface and your own observer model. So in a lot of cases, just make your own, right? But if you like this and you just want to practice or play with it, certainly the stuff is there for you to do that with. All right, so what resources will I point you to? Well, you've seen some of this before. I've passed along the Design Patterns book in some other lectures and the Headfirst Design Patterns. This is the definitive scholarly reference book. This is a fun, quirky, odd kind of book that has some fun stuff in it and a very different sort of easier to fun to digest kind of stuff. So those both have some, of course, have good merit. And then if you want to do design pattern intros and you want to talk about specifically Observer, here's some references that you could follow up on. So pause this slide if you want to copy all of those down. I guess I should be nice and copy and paste all of these into the links in the YouTube videos so that I wouldn't have to make you stop and copy them. Sorry about that. So hopefully that has been a useful and interesting introduction for you to the world of design patterns, especially the observer design pattern, which is a useful one. Those of you who are in my class, we're certainly going to be doing a sizable project using Observer, and so you will get a good chance to practice it. And we'll also go through and do a UML sequence diagram. We may not have really used that before, but if not, this is a great time to introduce it because we kind of want to pay attention to what stuff happens in what order and how we know where the information goes, right? So a sequence diagram will help us to make sure we're clear about how this all comes together. So thanks so much for watching this video. Hope you're finding them useful. Leave a comment below if you have questions or want to comment on anything else. So thanks for watching, and we'll continue with our Java 2 course with some other videos. Thanks.